This is the Charles H. Castle Elementary School in Bakersfield, California.
You see some round things?
Teacher Kathy Scrivener has been exploring circumference and diameter for the last 2 days with her 4th grade class.
What did we do yesterday to learn about circles? Ian?
We drew a circle and put the center, and we did we did diameter, and what was that word again?
The R word?
Yes. The radius.
Radius. Look over here. We have our vocabulary words written on the board over here. Let's read them. Radius, diameter, center, compass. Radii. Daniel, how did you tell us we could remember radii?
Radii has 2 eyes and it stands for 2 or more.
I would like to pick maybe the octagon team, and they did a good job in the activity yesterday. Can you show us and remind us what we did on the floor yesterday to study circles? Okay, first, what did you do?
We took the pencil and we stuck the string around it, and we put it in the center. Then we went out as far as the string goes, and we went around.
Perfect. You have the pencil as the center of the circle, and then you're using the string as the what of the circle?
As a radius.
As a radius of the circle. Can you remember where we learned about circumference in math before? Chris?
We used a pumpkin to learn about the circumference.
Okay. What was the circumference of the pumpkin? Can you show me with your arms? Show me with your arms? Okay. Close your eyes and picture you have a big pumpkin and you're giving it a hug. Okay? A big pumpkin. Now hold your hands that way. Now open your eyes and look. Look at your arms and look at your body. That is the circumference of the pumpkin. Okay? Alrighty, we know all about that. Let's look at the word circumference. Okay, I want you to look at this word. What do you see that's the same in those 2 words? What letters do you see that's the same in those 2 words? Let me see. James.
Circ.
Circ. Right here. Okay? All right. Now, there are some other words that have circ in them. Do you know why a circus might be named a circus? What does it have to do with something round?
They have the different rings that they do stuff in.
Excellent, excellent.
They call the circus master the ringmaster.
Good for you, that's excellent. That's exactly right. So all of these things have something to do with something round, right? Okay, today what we're going to do is we're going to see if we can discover a relationship or something that is special about the circumference of a circle. Do this with your hand and think circumference. Circumference of a circle. Now do this. And the diameter of a circle. The diameter of the circle. Good. All right. I would like you to get out your math kits out of your desk, please. They have a large Ziploc bag that they have materials that they need for math. And depending on where we're working in math, those items can change. So in your math kit, I want to make sure that you have a centimeter tape. Can you find your centimeter tape? Pull it out, and if you have it paper clip, please take the paper clip off and put it back in your math kit so that you'll know where it is when it's time to put it up. Good for you. Okay, pull out your centimeter tape and have a look at it. We're going to be measuring in centimeters today. Say that word. Centimeter. You can see what a centimeter is. Okay? Good. And when you're measuring, I want you to round off to the nearest centimeter. I have a chart for each team. We are going to use this chart to collect some measuring data. Okay? James, you're right here. You have a good look at this. Can you tell me what data means?
Like collecting information to find something out.
Good. To find something out. And we are going to discover something, and we are trying to find something out. So it looks to me like you are going to find some items around the classroom, and you're going to measure the what? Circumference of an item. So can it be a pencil box?
Yes.
No.
Maybe. What about this?
Diameter.
Diameter. Do you think that it would be something round or square or what?
Round.
Round, probably round. All right, what we're going to do today is we're going to measure some circumference and some diameter of things that you find around the room. And I want to see you exploring the room. Pencils should be down, eyes should be on me. You're going to be searching around the room for round things. Round things. You're going to measure the circumference and the diameter. Next, I want you to come to a team consensus and come back to your team and record that data. All right? Let's get busy. All right, we're going to record some data we're going to share some data from each team. Rhombus. Rhombus team.
The clock.
The clock. All right. What was the circumference of the clock? Hold the clock up.
110 centimeters.
110 centimeters. Okay? And the diameter?
8 centimeters. 34.
34 centimeters. Okay, let's go to the quadrilateral team. Chip, what item did your group choose to share?
My head.
Your head. Okay. Is a head a round item? Is it a circle? No, I'm looking down on Sandy's head right now. Say this word, ellipse. Ellipse. Show me what an ellipse looks like with your hands, this team right here. What does it look like? What's another name? Oval. I don't think that one's going to work for what we need to do. We need to have circles, but that gave you practice measuring, so that's okay. Allison, what do you have?
We have the cork. We measured
what?
our cork.
A cork.
The circumference was 6 centimeters and the diameter was 2 centimeters.
6 and 2. Is this a big item or a little item? This is an easy one to look at the comparison. This is something that you should all look. You too, isosceles triangles. Look at this one. This is the cork. Something here, something here. Trash can. Can you hold the trash can up and show us? That's fine. I think we can see it. How much?
We got 150 centimeters for the circumference.
150 centimeters and
25 centimeters for the diameter.
25 centimeters diameter. I want you to look at something and see if you can quickly come to a decision about what you found from this data. You may not be able to figure out. I'm going to tell you how to do it in just a minute, but I want you to do some thinking. This one right here might give you a clue. It's the easiest one to see. This one right here, look at this one and this one. Think about your multiplication facts. Right here and right here. Those are the easiest one to see. Is there a relationship between these two numbers that these two numbers share? Does anybody at all see it? James thinks he does. Put your heads together and talk about it for a couple of seconds.
It's this small, so it should be like 6 centimeters.
Yeah, but on their cork, it did say that. It says 6 centimeters. Well, it's got to be something with the times.
Yeah, it has to be.
It might be that, well, what was one of the 34? Well, what times what? 2 divided by...
I think somebody, a couple of kids have come up with it. Look closely here. Did you see some similarities with the pentagons? What do we have here?
It's times 3.
It's times 3. What's times 3?
It's 2 times 3.
2 times 3 is 6. They do work with calculators. It worked into the lesson beautifully because, of course, these children have not been exposed formally to the algorithm of division. The calculator gave them an opportunity to look at these numbers and be able to do some division. I would like for you to put this problem. Circumference divided by the diameter equals... I wanted them to see that there's a ratio between the circumference and the diameter. You could see there were some related numbers there. Some multiples of 3 were pretty obvious. 6 divided by 2 is 3, okay? Do this one. 20, this one right here with the star. I pointed out a couple that I thought they could focus in on because the children had a lot of incorrect measurements. They're still exploring measuring. They're still exploring what diameter is. Paul, what is on your calculator?
2.8571428.
Holy cow. How can we round this off? Okay, in like dollars and cents. Okay? Ian, how can we round that off to dollars and cents?
The 7 is above 4, so it rounds the 5 to $2.86.
Yeah, $2.86. Many years ago, we probably would have just handed out a sheet of information. This is the circumference of this circle. This is the diameter of this circle. And the children would do the division and get the answer and try to find out. And it would all be perfectly correct. But when they have gone around and hunted for data themselves, that means something to them. They know what it is, for one thing. I don't believe there's a child in this class that didn't know what that column stood for. It's the circumference of that round thing we measured. They know that. And so that is really meaningful data. It's not just a bunch of things that you need to get done and get it handed into the teacher.
How did Miss Scrivener have students develop ownership in mathematical tasks? Discuss the techniques used for teaching the relationship between circumference and diameter. Would it have been valuable to have students do a second measurement?